Hi everybody, how's it going? So today I'm just making a video about the benefits of scrapping the graphing calculator in the classroom, which looks sort of like that, and moving towards using Desmos instead. In particular, I'm going to be talking about the quadratics unit in grade 11 Applied Math. So the reason why I decided to talk about this is because I just feel as though the software is so much better than using a graphing calculator, and it really gets the point across more so than the graphing calculator does. So if we just take a look here at the quadratics unit for grade 11 Applied Math, some of the things they're expected to do is to determine with technology the intercepts of the graph of a quadratic function, determine with technology the coordinates of the vertex, and to sketch the graph of a quadratic function as well, and to solve with technology a contextual problem involving data that is best represented by a quadratic function graph. So here we can see the TI-84 Plus calculator. It's pretty much the standard calculator that's used, in my experience anyways, in classrooms. And I'm just going to go ahead and put a function in here. So you hit the y equals, and let's say y equals x plus 3 times x minus 2. Close the bracket, hit the graph button, and there we can see the graph for y equals x plus 3 times x minus 2. Now if I wanted to, for example, find the intercepts of the graph, I would press second, trace, because there's the calc on top there, and then the 0 button. So that's number 2. Now it asks for a left bound. So say I wanted to find this x-intercept on the left. I would need to use the arrow keys to move to the left side of the x-intercept. Hit enter. Now it's asking for the right bound, so I'm just going to go to the other side there. Hit enter. Enter one more time, and we see that there is an x-intercept at x equals -3. Now if we switch over to Desmos, I'm just going to enter the equation in here again. So y equals x plus 3, x minus 2. Here's the graph here, and I can just click on that point and see that -3 is an x-intercept. And I can also see that +2 is an x-intercept. So whereas the graphing calculator took me about a minute and a half to punch everything in and find the x-intercept, using Desmos took me about 10 seconds to type it in and 2 seconds to click on both intercepts. So essentially, I saved myself a good minute plus using Desmos, just trying to answer that question. So going back to the graphing calculator again, I'm just going to showcase how to find the vertex. So first thing we need to notice is that this is a quadratic that is opening upwards, which means that it has a minimum value. So I have to go to second and trace, and minimum is number 3. So I'll hit number 3. And we have the left bound, right bound again, but now we're doing it around the vertex here at the bottom. So I'm already on the left. I'm going to hit enter. I'm going to go over to the other side. Hit enter. Enter again. And we see the vertex is at -0.5 and -6.25. But if we look at Desmos, well, I already have the equation in here. And I can just click on that point, and there it is, -0.5, -6.25. Another point that they give you is the y-intercept, which is at -6, which is also pretty handy. So yeah, all that work that I did with the graphing calculator, it takes a fraction of the time using Desmos to get the same answers. So now if we take a look at a real-world example, I have this question here that I found about throwing a ball. And it says, a ball is thrown straight up from 3 meters above the ground with a velocity of 14 meters per second. When does it hit the ground? And we can see here that there is an equation that I will punch into the graphing calculator. So we have y equals -5x squared. The graphing calculator only lets you use the letter x, but that's okay. We can change from t to x, doesn't matter, plus 3. And when we graph it, we get a graph that looks like that. So if this is the arc of the ball, it's going to hit the ground right here, because that's where the height is 0. So we want to find the x-intercept. So we'll go second, trace, number 2 for the 0. Left bound, we're already on the left, so I'm just going to hit enter. Right bound, we want it to be on the other side of that point. Enter, enter. And we see that it hits the ground after 3 seconds. We can also find where the height of the ball after 2 seconds. If we go second, trace, and we use the value function, and now it's asking for what x equals, so we want x to equal 2 for 2 seconds, and we see the ball will be 11 meters high. Now if we wanted to do this using Desmos, we could just enter y equals -5x squared plus 14x plus 3, and just click on that point, and we can see that the ball will hit the ground after 3 seconds. And if we wanted to find how high it is after 2 seconds, we can make a second line at x equals 2, and click on the point where they intersect, and we see that the ball will be 11 meters high after 2 seconds. So again, it only took a fraction of the time to find the answers using Desmos. Finally, another benefit of using Desmos is that they have activity bundles. So if you look on the left side of the page here, there are bundles for all different kinds of functions and so on that you can use. So if we look at the quadratics, there are things like shooting a basketball, different features of parabolas. There's a game called Marble Slides that you can play, card sorting, and you can also make your own as well. So I'm just going to go into my custom activities here, and here are some of the activities that I've made. So for example, the matching quadratics one. There are things like this is what I made, matching x-intercepts to their equations, matching to the axis of symmetry, matching axis of symmetry and vertex, matching equations with their graphs, matching between standard form and factored form. And again, these are just samples of things that I've created, but there are so many different tools that you can use to make your own activities.
going to highlight a couple of apps here. One of them is called Quadratic Master, and the other one is called Photomath. So Quadratic Master is only available through Apple's App Store. The reason why I decided to check it out is because it has a 4.5 star rating on the App Store. But unfortunately, most of the features are hidden behind a paywall, and it costs $2.79 for the full version. So in the basic version, you can only enter a quadratic equation in vertex form, and it spits out a bunch of info basically, but there's no explanation that goes along with it. It might be good for students if they want to use it to check their answers, but it's not really useful for any kind of learning if they're just getting answers out of it. Photomath is a free app for iOS and Android. So what it is you can take a picture of an equation, and it can be typed or handwritten, and it'll also give you a bunch of information, but with additional explanation. So here you can see I wrote an equation in standard form, and it gave me the option of seeing it in vertex form or intercept form. It also gives explanation on finding x-intercepts, the y-intercept, domain, and it also gives you a graph. And when I click on the solving steps for finding x-intercepts, it's broken down step by step. And if I tap on one of those steps, it breaks it down even further. So for this unit, I would highly recommend this app for learning, but it's also good for learning pretty much any kind of math.
And just one website I wanted to highlight here is Khan Academy. So Khan Academy has a ton of lessons and problems that any student can work on. There's a whole unit here, as you can see, on quadratic functions and equations. So just taking a quick look through here, there's an intro to parabolas, solving and graphing with factored form, vertex form, and so on and so on. So that's just another option if you wanted to try something different. So just coming back here to the curriculum document, I just want to point out again that we are supposed to be using technology to teach this unit. So why don't we use the best technology that's available? Like, when we look at the graphing calculator, you could see how much trouble I was having with trying to figure out what the x-intercepts are. In my experience, students have a hard time figuring out their left bound and their right bound, particularly when the quadratic equation is steep in those areas, and they had trouble trying to figure out the concept of what was left of the x-intercept and what was right. Another issue that I find with the graphing calculators is that when you're trying to find the vertex, like, you have to specifically look for minimums or the maximum. And, you know, there might be issues with language with students, like, what if they don't know what the words minimum and maximum mean? That's something that you can teach them, of course, or you could just get them to use Desmos, punch in the equation, and just click on the point that's at the bottom, and it gives it to you right there, versus fiddling around with the graphing calculator for half an hour trying to get them to figure out how to use it. So that's just a couple of examples of why I believe that Desmos is a much better tool for teaching this unit versus using a graphing calculator. And also, when they move on to grade 12 applied math, they're doing things like finding the regression or the line of best fit for cubic functions, exponential functions, log functions, and sinusoidal functions. And Desmos can do all of that too, and it's a lot better than using the graphing calculator. So I'm hoping that this at least gave you something to think about. Perhaps you'll think about changing how you teach this unit, perhaps you won't. But in my opinion, Desmos is the best tool for teaching this unit. Thanks, everyone.